Thank you, Professor Hong. Good morning, everyone. First of all, I would say thanks to Anchor and Professor Zhao Zhongze for inviting me to share some research progress we did these years with you. And the title of a paper in the proceedings is this one, but a week ago, I decided to change the contents. So what I'm going to talk is about progresses on stream-based seismic dynamic controlled performance evaluation method for steel bridges. Yeah. Here shows outline of my talk. First, introduction, and second is introduction to steel double ribs arch bridges we used for analysis and evaluation. And the third one is to show the process of seismic performance evaluation. And then we use the BRB to improve the performance of this bridge, and also make some evaluation. And finally, the conclusion and future workers. During strong earthquakes in past several years, local buckling of braces were observed. For example, this photo shows local buckling, not the local buckling, sorry, global buckling of braces in Kobe earthquake. And so analysis method to accurately evaluate buckling of braces in steel bridges is of significant importance. In Japan, nonlinear analysis has been widely employed to evaluate performance of complicated steel bridges. However, this method cannot consider the effect of local buckling, but it can simulate the member buckling, that means global buckling, as long as a proper modeling is employed. In JACE, Japan Society of Civil Engineers design specifications, there are two methods available for performance evaluation. One is a deformation-based method. In this method, about 20 years ago, our research team proposed a stream-based evaluation method. And 5 years ago, we JSA specification team also provide a new method that is force-based, using inertial forces, something like this. But these years, many engineers from design company told me that the stream-based method is quite easy to use. Yeah, so, but there are some unclear problems. For example, how to consider the effect of global buckling. So we proposed a method to accurately simulate the behaviors of braces in steel frames and cyclic loading in 2020. Yeah, published in a JACE paper, journal. We compared with initial deflection method. We found that the proposed initial lateral load method is based considering both the reliability and analysis stability. Yeah, this is usually no deflection, and the initial in the past initial deflection method is usually used, but the way found sometimes analysis is not convergent. So we propose a new method to consider this problem. And the aims of my talk is three. One is to verify the applicability of IIRM, initial lateral load method, to actual bridges. Before this, we just check on steel column or frame, yeah, and but we check again to using actual bridges. And the second aim is to illustrate the seismic performance evaluation using stream-based method. Yeah, this method is verified on steel piers, frames. But this here we checked on steel bridge. And the third one is to show improvement of seismic performance by replacing diagonal braces with BRB. Here is a picture of steel double ribs arch bridge conducted by Dr. Sano in 2005. The paper is published in 2007. Yeah, the span is 13 meters. So in his paper, two specimens with different Vedas thickness ratio were checked. This is box section. So Vedas thickness parameter is a key point. It is a key parameter. One is a symbol. RF is a parameter. This parameter is similar to C2 in AIC. Yesterday, Prof. 1, not exactly the same, yeah, but it's similar to that, I think. BOT is relatively large compared with building sections. Yeah. And loading program is that we also did load here, yeah, and the lateral displacement were applied to the arch crown. This is the loading program details. And here shows the definition of RF plate with the thickness ratio parameter. We also consider the effect of properties of material. Yeah. But as in AIC, maybe yesterday Professor Wang didn't show this term, but in JSA, we usually this one, but very close. And this is a model, half model of arch bridge because of symmetries. Yeah, and this end segment is a key part. We draw such a figure like frame, and using two models diagrams. We use the bilinear kinematic model for this analysis, and first we use the beam eminence. That's a fiber model, and to better consider the effect of local bracketing. So we also use the hybrid elements, B elements, and sometimes some location we use the shear elements. Yeah, and this is here is a simple spot, so moment is 0. So critical segment in this part is these locations. Yeah. And we follow the test details and model the condition, boundary condition like this one. The problem is how to apply initial lateral load and how to calculate initial lateral load. And we propose a set of formulas like this one. Yeah, for rectangular and pipe sections, we use this formula. And for box section, we use this one. For H and cut T sections, we use this one. Like it is according to ACCCS curves, the different parameter, different equation. The Q error over sovereign is calculated by this equation. And then, so initial lateral load can be calculated according to various cross-section of cross-section shapers. Yeah. So another problem is to add, how to add this load. That means directions. We first performed a pushover analysis and found the diagonal braces deformed upward, and the rest deformed downward. So we just use the route from pushover analysis and the same directions. This is skip it. Okay, in the strain-based evaluation method, we use this format. This is very common. Yeah, this is responses, and this is limit value at the capacity. Just to check this equation. In this study, we just use partially conformity gamma as 1.0, and there are several limit states for steel bridges. For members, which to consider these: member buckling, local buckling, or couple member local buckling, or repairability, that is serviceability, yeah, and deformation, low cycle fatigue. For whole structure, we check peak load or 95% peak load. In JRA, Japanese national rule, this usually is peak load, but in JCE specifications, we use this one to better use the performance of steel. And also, we have to check peak displacement. So how to get the response? Just perform a nonlinear analysis and to output strains, and then to average it. We use the average strain concept here. And limit states to against the level 2 earthquakes. Usually, first one is local buckling, and the second one is repairability, and the third one is 95% peak load. This is JSCE format, and limited states of BRB. We just check the deformation, for example, 3%, and also check local low circle fatigue, for example, CID using CID index. Yeah. And the process is usually the first one is to just perform a preliminary design according to level 1 earthquake, moderate earthquake. That's usually a limited states design. And the second step is to check the performance with structural safety is okay or repairability is okay. Repairability is usually we define the average maximum value of average strain is less than 2.0 epsilon y, the zero strain. But the structure safety, which we check this value with epsilon u. Epsilon u is the limit of failure strain of the sections considering the local buckling. We have a set of formulas to calculate this value. And in this study, we checked the arch rib on main member, that's the box sections. You should keep integrated level at 2, and the detailed values given here. Also, we check the second member, for example, diagonal brace or lateral strut. Yeah, that's also we call it lateral bracing here. Yeah, to using these values to check that. This is given in the JCE specifications. And then perform analysis, yeah, to use detail load, and also put the initial lateral load to consider the member buckling, and finally to put the lateral displacement here, push over, and then cyclic analysis, perform the two analysis. Yeah. This is a beam analysis result. This is case one, is thin word section, and relatively thick word, case two. And this is a test result. And red line is a result of pushover analysis, and dashed line is a result from cyclic analysis. The skeleton curve of the cyclic analysis results can be approximately simulated by pushover analysis. Yeah, it's almost the same. But for case two, deterioration of the loader carrier capacity due to the P delta effect, a little different. Yeah, can be slightly verified for the cyclic analysis. But the comparison between test and analysis, we can say that for the analysis results, decreasing of the load is very slow. Yeah, during the post-peak range, during larger scale. Yeah, and this one is test results, but we cannot consider this phenomenon. So we can say that the deterioration of loader carrier capacity of systems is mainly dominated by local buckling. But we use the beam elements fiber model, so it is difficult to, it is impossible to consider the local buckling. And then we also perform the evaluation. Yeah, so here shows yield displacement of this bridge is 40, and from our method, seismic performance evaluation, ultimate limit space is 59.9. So the ultimate displacement is larger than the yield displacement. Seismic performance can be verified as safe enough compared with displacement at the peak load or that of 95% peak load. Yeah. And compared with case one, cross section of arch rib of case two is about 1 times. And the ultimate displacement delta U is increased about 1.38 times from this value to this value. And this means that strengthening effect can be obtained by using thicker plate. Also, for both cases, predict the instant when local buckling of lateral abrasions occurs is a bit early than the test results. The test is here. Yeah, a little early. Indicate that the method can will predict one of failure models leading to deterioration of the capacity. And then we also use the beam shear hybrid analysis, and here shows results. And this is a critical part. We use the shear element to modulate, and this pushover and analysis results are shared with is computed with test results here. And for peak point, for peak load, yeah, the beam analysis is quite larger than test results. But for beam shear hybrid analysis, it is a little bit larger, but it is close to the test results. Yeah. And so beam shear hybrid analysis can capture deterioration of the capacity. Since local buckling can be considered in this model, so deterioration of loader carrier capacity can be reproduced, yeah, in this method. And we also try to improve the performance of this bridge. So we just show case 2 here using 2 types of retrofit method. One is we call the LBS1, just like this, and another one is LBS2, like this one. We also strengthen the lateral braces using a thicker plate to change the thickness from 3.2 to 5.0. Yeah, we compare these rods. The problem is how to design the BRB. Yeah, we should determine material, and we should determine the cross sections. First of all, of course, we just by trial and error and gave some initial values for the analysis. Yeah, take a random values. And when the urine load is too high, yeah, the BRB no urine observed. Yeah. And if the urine load is too small, the loading carrier capacity decreases significantly. So, it's necessary to determine the appropriate initial values of BRB to improve the seismic performance. And for these purposes, we performed 21 cases, and finally found that such a combination is good to do that. This is detailed results, yeah, and we check the performance of bridges. And then also use a similar procedure to perform performance evaluation. Yeah, this here is for arch lip the same. The integrated level is 2. For diagonal brace or BRB, this is integrated levels are 4, and using these values to make a check, the response should be less than to capacity. Yeah, this is capacity. Yeah, and we also check the performance of BRB using this equation to calculate the deformation, and use this equation to perform check of low circular fatigue. And finally, we found that for both cases, we can obtain stable curves. Yeah, we can get stable curves. And for pre-retrofitted motor, that without change diagonal braces to BRB, peak load is obtained at 0.3 is here. But for retrofitted motor, case 1 or case 10, peak load occurs about 0.7 in the curve. This means no, we only perform the analysis here. We can perform any more, but it's just compared with test results. We can say that no tendency of loading carrier capacity deterioration observed. So load carrier capacity sustained till larger deformation. This is one phenomenon. And for this is damaged situation for 3 cases. For all the analysis, strain mainly concentrated at the lateral braces, lateral struts. Yeah, but compared with the original one, the average strain is reduced about 70% for case LBS1 and 7% for another case. Yeah. So also we check the damage of main member arch lip. For the strap, for the retrofit motors, the damage of arch lip observed is reduced from 11 epsilon y to 1 or 4 epsilon times 4 epsilon y. Yeah, is largely reduced. And reach the models, but show the damage to diagonal braces in the second part. Yeah, we only changed, we only replaced this part. So it is necessary to also replace this part. We did, but due to time limitation, I didn't show the result here. And we also checked the displacement. For example, ultimate limitless deformation for rich fit model, delta U is larger than of this one. And about 1.1 compared with two models, 1.2 times in LBS1 and 1.27 times in this case. And the ultimate limitless deformation of LBS2, delta U is decided by lateral braces. Second, that means second members, not the main members. So damage to arch livers, can be reduced. And so we can conclude that the seismic performance improvement by BRB installation is obvious. Yeah. Also, we checked the performance of BRBs. This is the capacity we provide for BRBs we developed. And this is response. So this is quite smaller than this value. So BRB is still very good. It can work again for next earthquake or something like that. Yeah. So this is check the result. BRB can meet the requirement performance up to the ultimate state. This is we changed the 4 diagrams. This one. So result becomes much better. No damage observed in main members. Yeah, only a slight damage here. Yeah, finally, conclusions of my talk. So damage locations can be generally captured by beam element analysis. And the beam shear hybrid analysis can reproduce local buckling. Therefore, it can simulate the deterioration of loader carrying capacity as observed in the test. From seismic performance evaluation using this strain-based method, the damage locations, and I didn't talk about the squares, but the squares in the post-peak range are consistent with experimental one. So applicability of initial lateral load method for the this kind of bridges is confirmed, and seismic performance verification using the strain-based method is illustrated here. And for another part, yield strength of this installed BRB has a significant effect on structure performance. By installing BRB at the end segment, that first part, a large deformation in the pre-retrofitted model can be barely observed. In addition, damage to arch lip and lateral brace is reduced. By thinking diagonal braces or replaced by BRBs, ultimate strength, ultimate limit deformations increases. And we can see that seismic performance improvement of steel double ribs arch bridges is achieved through strengthening the end segment. Also, for the beam shear analysis, it is necessary to reanalyze the local buckling and the fracture of lateral braces using shear elements. So to this end, we are performing some tests on braces these years to get experimental data and then to check our analysis procedure. In this study, only parts of arch lip member with large strain are simulated by shear elements, and the shear elements may be improved for whole segment to further verify the accuracy of this study. Yeah. And also, in order to analyze the collapsing process of steel bridge, it's necessary to develop an analytical tool for the low circle fatigue evaluation, which can then simulate failure of braces from local buckling to fracture. Yeah. This is what to perform this analysis. We are doing some tests on braces these years, and we will summarize the results and perform analysis to check our method. That's all from my presentation. Thank you for your attention.